Hello, I would like to introduce Mehmet Aksit, who talked about the role of computer science in the new Industry 4.0. Hello.
Hi, thank you.
So maybe at first, how would you define the term Industry 4.0?
Well, actually, my talk was more than Industry 4.0 because actually my talk was about recent trends in industry. So traditionally, Industry 4.0 is defined as certain characteristics, and mostly this means more and more application of computerization to industrial processes with intelligent computers, sensors, programs, network computers, self-learning, self-adaptive systems. And it's claimed that Industry 4.0 is the fourth revolution in industrial revolution. It's the fourth step. In my presentation, I presented the recent trends in industry from a more general way. And my conclusion was that there is no a revolutionary change, but it's an evolutionary change. And Industry 4.0 is the subset of what we are observing today. So the idea is not to talk about hypes and these kind of things, but to be more realistic or scientific in observing the facts. So Industry 4.0 is an observation of certain ongoing activities through the application of computerization to industrial processes. I think it's good to give names to it, but it's difficult, or it's not also desired to restrict it. So in that sense, you can call it as a computerization of industrial production. But in my talk, I gave more items which they don't necessarily associate these with Industry 4.0. So I was more general than Industry 4.0.
Yeah, right. So maybe, as you've just mentioned, it's a kind of computerization of the whole industry manufacturing process. But you are going in your maybe definitions. You are going much further. You take a look at it much wider. So, where would you see our perspective, our role? I mean, the IT role in those new changes, in that evolution of the industry.
So basically, the trends, let's put it in trends in manufacturing processes, computerization touches, the computerization process touches almost every field of computer science. So some people see it purely as psychophysical systems, but of course, algorithms are also important. Of course, AI is important. Of course, distributed computing is important. Platforms are important, and so forth. So it touches every area within the computer science domain. So in my talk, I have listed some recent trends in computer science. And in particular, however, there are two areas that I particularly focus on. These are so-called software technology or software engineering areas, because if you have a bright idea in AI or big data or machine learning or whatever technology you are working on, in some way these techniques must be adopted by companies and must be manufactured or at least used in certain products and turn into economic value. If you cannot produce your ideas economically, then nobody will adopt it. So therefore, their software technology and software engineering concerns are crucial. So in my talk, I presented the recent trends Industry 4.0 is a subset of it. And I said, okay, all these computer science disciplines are related in some way, but software technology and software engineering concerns are very crucial because they are so-called meta-level concerns, and they are very crucial in economical realization of all bright new ideas. So therefore, I have focused in particular the software technology and software engineering concerns in the end. So one parameter is recent trends in industry, which demands heavy ICT usage. Secondly, ICT, computer science is important. We have a bunch of topics in computer science, including cyber physical systems, AI, and so forth in a broader sense. And thirdly, we need software technology and software engineering principles to economically realize them. So that was the chain of reasoning in my talk. In addition, I talk also about universities because you cannot realize all these developments without the support of universities.
Exactly. So when taking a look at all those changes going on in industry, on industry level, maybe let's take a look at, once again, at our perspective from the point of view of the IT specialists, all those programmers that are maybe at the moment learning, and what would you advise them? What would be your advice? Do we have to change? Do we have to apply any changes to ourselves to adapt to the changes that are going on in the industry, or can we stay as we were until it started?
Well, of course, as an IT specialist, we should be aware of the trends and developments and prepare ourselves, at least to guarantee our job in the future. But this is also true for the companies. So the companies must be aware of the technological trends and developments, and also must be able to observe the opportunities there and prepare themselves. Not all the activities can be realized by companies, so you need also university support. So in my talk, I have made a list of changes as IT specialists, which, for example, nowadays what we see is that companies become specialized in certain products. So there are companies that produce television sets, some mobile equipments. Some companies are specialized in, let's say, medical equipment. Some specialize in banking systems or banking transactions and so forth. So we don't have any more ad hoc projects where companies maybe not that much at least, or getting increasingly less, that a company is assigned to ad hoc projects. So it needs specialization. From that perspective, given all the trends in industry, I have observed a number of important changes within IT too. So this is based on a large-scale cooperation with industry. I have worked with 5 very large companies. Most of these companies have at least 300 engineers and more. For example, they build helicopters, radar systems, and so forth, or industrial automation. So I indeed work with large companies and defined actually a process to make these companies better, and also their IT personnel better, and also to let them work together with universities. But we have observed some trends also within the ICT. So one important thing is that based on this specialization, we see more and more product lines instead of product development. Product lines means that a company develops family of products instead of dedicated single product. And if you don't use the processes and mechanisms or techniques to build product lines, you will have to repeat everything again and again. So in order to gain the benefit of sharing and reuse, you have to really have a different mindset and different process and different technology. So my first statement is product lines instead of products. Secondly, especially I was working with large systems. Every system has to be integrated in a larger context, has to work together with other systems. So-called systems of systems. That means systems can be integrated and in a coordinated manner, and you obtain larger systems. Think about, for example, airspace control systems or factory automation systems and many other systems, because they are networked and connected and so forth. So you inevitably you get systems of systems. This needs special care, so that every subsystem, even at the moment that you are designing it, is working alone by itself, it can be connected into a larger context. So you have to prepare your system for a larger context, which is called systems of systems. The second point is that systems of systems instead of systems. So if you have time, I have more of these lists. For example, ecosystems instead of a platform design. For example, auto-adaptive control instead of components without any adaptation and control. For example, distributed algorithms, distributed problem solving instead of single monolithic centralized algorithms. For example, model-based development instead of programming from scratch. Model-based development means that you develop models for a particular domain, and for example, you generate code from it instead of writing everything in plain programming languages. Usage of plain programming languages decreased to about 20-30% now, and it will be much less and less, especially because companies are specialized in certain product domains. So I have a couple of more if you want. Yeah.
Well, okay, so I would say that is already a lot, but do you see any new requirements for IT specialists in the area, I would say, of those soft skills, probably?
So the new requirement is that there are many things happening which is out of control. So you can say, okay, I don't care them, I don't take care of it, or I don't mind, but then in the end you will be out of the process. So basically we should, as IT specialists, have problem solving skills, and our solutions are expressed in software architecture, software systems, software hardware systems, and so on. So in order to cope with the demands of today and tomorrow, we have to, of course, solve the problems of today and tomorrow. If indeed companies are producing these product lines and they have to, bring very new versions in a very fast way, and then the software should be utilized in a fully and so forth. So there are some techniques needed. For example, the domains that we are operating in, you have to have the domain knowledge. But so two things: you have to have the domain knowledge, but because software evolves and changes and new functionalities must be added, basically you have to understand and know the adaptation and change techniques very well. So there are about, let's say, I think 40 or 50 different kinds of adaptation mechanisms. So in the end, it boils down to the following. For economical software, you should commit to what is known. These are the invariants in the problem domain. For example, you build a television, there are some essential things that must be there, like video processing. Manage what is unknown. Managing what is unknown means that actually knowing the mechanism that can help you to deal with changes, extensions, new functionalities, change of platforms, and so forth. So as an IT specialist, you better know all these adaptation techniques or generation techniques and composition techniques, whatever. So that's just most of the time knowing design patterns or knowing model-driven engineering, code generation, and so forth. So be aware of all the technologies that are needed, plus know how to do domain analysis and model building, instead of just memorizing a particular product by a vendor or programming language. So it's shifted from programming language or vendor knowledge. Before you had to memorize maybe all Windows system calls and so on. Now actually you should have skills of building models and knowledgeable about all adaptation techniques that are necessary.
Right, because in the end, we are all supposed to solve a certain problem that appears somewhere,
Yes.
right?
So it's all about problem solving, but the problems reflect actually the trends in industry, which is very agile, changing and evolving. And therefore, all these techniques like product lines, like systems of systems, like model building and so forth are necessary, plus management techniques like design patterns, adaptation mechanism, dispatch mechanism, generative mechanisms, and so forth. So it's quite logical, actually, but computer science has changed a lot. So especially software technology and software engineering changed a lot.
Okay, and from the academic point of view, do we have to, or do universities have to adjust to those changes too? Should they change the way they keep on teaching students? Should it happen quickly, and maybe how big those changes should be?
So traditional universities, unfortunately, cannot cope with the changes, and this we also observe that hardly any academical contribution recent years, recent decade turn into a value. Before, what we see when for example, when Unix was introduced or when some other fundamental techniques were introduced, universities were part of it. So the traditional work of universities, research and education, they must actually change dramatically. What happened now is that universities became their own stakeholder, and the whole process is disconnected. The university processes are disconnected from society and industry, and the whole objective of university turned into getting degrees and writing papers and getting degrees, and so it becomes a self-reference kind of system where everybody is happy within the university system, maybe, or unhappy, but it sustained itself. In the end, universities are meant to serve society and the country and humanity and so forth. And we cannot do it without serving industry and society. So therefore, we have to get open again. It is not the intention that somebody becomes a doctor or a PhD or a professor. It's nice, but of course, if you only think it from your own career perspective, it's a very egoistic way of looking. So therefore, we have to change completely. So all the specializations, I believe, must be derived from the needs. That's point one. The academic personnel must be able to work in multidisciplinary teams. So you cannot only have a small group only work in your own area, but you have to integrate different disciplines together. So you have to form networks, and academic personnel must be proactive in forming networks, in connecting with other academicians and so on. And they have to adapt themselves in changing trends and so on. So not only refer to what is needed, that means you need analysis of strategic plans of companies and country and so forth, and must be able to serve it. So you have to find out actually what they need from academic people, and you have to somehow take a role in it. So say, okay, I want to serve the country or humanity or society in this way. So not only get PhDs or become professor or something like that, or publish yet another paper. So an education process must be mainly actually aim at problem solving and critical thinking. So I think personally, for example, critical thinking must be taught as a fundamental lesson in course in the universities. You have to learn only core concepts, and you shouldn't run after hypes. You should develop skills of requirement analysis, problem analysis, solution domain analysis, and solution synthesis, and justification and verification. So I think the whole academic material which we teach our students must be based, must be motivated, or must be driven by problem-solving skills. And universities must actually change to motivate or to support academic personnel and students to behave like this. So currently it's seen to serve society or industry is seen as a handicap or is an obstacle because it doesn't really count for any academic career. So we have to change also the award system for that. Yes, universities must change dramatically, and unfortunately in many countries like in Poland, like Middle East, they copied American systems or maybe European systems, but mostly American systems. But you can never be better than them in their own context by copying it. So you have to identify nationally, let's say Poland should identify its own national strategies, technical objectives, identify strong and weak points, and define, let's say, set of requirements. And these should be investigated from an academical perspective, and each academical person must take a role to serve the needs of the country. By copying well-known universities in the US, you can never be better than them. But actually you must have all kinds of reasons to be better than them. So I think we should really shift our mindset and create different kind of universities, and don't fool ourselves with ranking systems that are developed by some parties which is of their advantage. If you look at the well-known American universities, basically they sell education. Many countries, rich people from the developing countries or countries send their children to educate there, spend a lot of money. They sell basically education, and they don't need actually advertisement because it is since 100 years their names became a brand. Most of the time they have very lousy education. Their education is taught by many times people even cannot speak English and are there for maybe for PhD study. So if you look at also my discipline and many disciplines, there are very few well-known researchers in these specific technology domains. So in other words, in my domain, hardly people are from Stanford or MIT, but they sell education, right? So we shouldn't copy these universities. We should go for our own natural interest. Poland should decide on what is its strategical needs, strategical objectives, identify the key companies, develop its own national policy, and understand the trends, identify the technical challenges, and universities in Poland should be reorganized to serve the national needs. Otherwise, you will serve some global interests or global powers. Okay, you should develop your national strategy.
Right. Well, let's hope that we will gonna make it. That we as a country, we as group of countries, the world, and we as IT specialists, that we are all going to survive in that changing environment. Thank you for the conversation.
Thank you very much for giving me the opportunity. Thank you.